Hello my dear students. So in the last video we saw that how can we differentiate vectors, and in this video we will be talking about properties of derivatives of vectors. So now let us see what are these properties. So we already know that we have properties like product rule and quotient rule when you have derivatives of simple functions, right? Quotient rule, right? Let me write it again. And those things make our life easy, right? We know that if you want to differentiate fx into gx, so this you can just do the derivative of fx multiplied with gx plus keep fx as such and then multiply with the derivative of gx, right? Or we know that if you have fx over gx and you want to differentiate, then also you know that you have the square of the denominator function, then you have g of x into f prime x minus f of x into g prime x. So we know that without these rules it's very difficult life while doing calculus, right? So similar things we would like to know whether they are available for vectors also, and luckily they are. Okay, so it's time to be happy because we have properties which are going to help us when we are going to differentiate vectors. So let me just list the properties, and the proofs are very simple. So the first property is, we would like to know what is if I have a function au, a vector valued function, another vector valued function b, and you want to differentiate their sum, that would be derivative of the first function plus derivative of the second function, right? And then second property is, if you have the dot product of a and b, then it says that it is a dot db by du plus da by du dot b. So it's similar to you can see that this is similar to product rule, okay, but instead of simple product we have a dot product here, right? And then we know that we have cross product also. So here a and b both are the functions of u. So you will do it like this: da by du cross b plus a into db by du. So now you can see that for cross product also the property is there, right? The similar property like we have for product rule in simple functions, right? And the next property is, if you have a vector valued function a and you multiply it with a constant phi and you want to differentiate, then you can always take phi out and you can just differentiate your vector, right? And then I told you we also have here scalar triple product and vector triple product. So we have, if you have this scalar triple product, right, so how we are going to solve it? Here also we have the same property. You differentiate the first vector, keep the other two vectors as such with the same symbols, okay, and then you keep the you differentiate the second vector and you keep all other vectors as such, and then for the last one you differentiate the third vector and keep all other vectors as such with the symbols. So this is another property, and the last one is that you have vector triple product. So you have a cross b cross c. So that would be, now you have the first vector, derivative of the first vector, keep all the vectors as such, and then you keep all the vectors as such, the derivative of the second vector in the second term, and in the third term you keep all the others as such and you differentiate the third vector. Now you see, these are the beautiful properties which are going to help you when you are trying to find out the derivatives of complex functions of which are vector valued. So we'll just do one problem in this video. You see, these are very small topics, like very easy, but we have to complete it, right? So that you don't feel that you have left something, or if you see a question and it's very simple, so at least you should have an idea that how you are going to do it. For example, if I have a vector as 5u square I cap plus u j cap minus u q k cap, and then I have b vector which is sin u I cap minus cos u j cap, right? And the question is find the derivative of a dot b. So how shall I proceed here? So we will be doing here, you can use the property, it is a dot db by du plus dA by du dot b, right? So this is a as such, that would be 5u square I cap plus uj cap minus u cube k cap dot product with the derivative here. So you have to take the derivative of b. So you can take the derivative of b, that is going to be the derivative of sine of u is cos of u, and then derivative of minus cos u is plus sine u, right? And then for the second one you have to differentiate this a vector, so you'll get 10u I cap plus 1 j cap minus 3u square k cap dot product with b vector. B vector is here, so that would be sine u I cap minus cos u j cap. Now you know how to take the dot products. So you have the first term with the first term. So you have 5u square cos u, and then the second term with the second term plus u sine u, and then this term with this term 10u sine u, and then you have this term with this term, so that is minus cos u. Okay, so now you combine. So here you can combine these two terms. So you'll get 5u square minus 1 cos u, and then you have 11u sin u. So that's our answer. Okay, and if you do it like this also, first other way is you actually find the dot product. A dot b, you find it out. So a dot b will be 5u square plus I cap plus u j cap minus u cube k cap dot product with sin u I cap minus cos u j cap, and then now you take the first with first, so that is going to be 5u square sin u, and then the second with second, so that would be minus u cos u. So that is my a dot b vector, and now I would like to differentiate with respect to u. So that will give you, you are going to use product rule here, 10u sin u plus 5u square cos u minus cos u plus u sin u. Then also you can see you get the same thing, 5u square minus 1 cos u plus 11u sin u. So now you can see that this one here and this one here, they are matching, right? Okay, dear students, so keep learning. Like right now we are learning vector calculus. This is very important if you look at the application point of view. So keep learning, and if you have any doubts, please write in the comment box. Keep sharing this video and subscribe to this channel. Thank you.